Thank you, Google and GTAC for giving me this opportunity to speak at this forum. Yes. So let's get started. So about me, I'm Shreeshankar. As Kid mentioned, I'm working Adobe systems. I'm working in that part of Adobe systems which develops a product on the Flash ecosystem. So I deal with products like Adobe Connect, Flash Media Server, Flash Media Gateway, and have been working on the performance and user experience engineering topics for last 4 or 5 years. So what applications? So as I said in my brief, so I'll be talking about media streaming applications which are so ubiquitous nowadays on the internet. Right, so we have so the properties, typical, basic properties of these applications, and they involve streaming multimedia, right? Interactive real-time collaboration. When I say interactive real-time collaboration, it's all about humans, right? They are the primary consumers of these features and services. And SaaS delivery. That means the entire service is delivered over the web, over the internet. So some examples like VoIP or video conferencing or VoIP or video calls, or like enterprise rich collaboration applications which involves webinars, like features which involves webinars which have a lot of things like screen sharing and things like virtual classrooms which have real-time whiteboards and stuff. So some examples of the product lines on these classes of application include Adobe Connect, Cisco WebEx, Office Live Meeting, Skype, and GTAC, among others. So this is the agenda for the talk. Basically, I've structured the talk in 3 sections. We'll be looking at the first, why quality of experience is a risk, and it's more of a risk in case of such human-centric applications. We'll look at a specific case study with respect to VoIP, quality of experience problems, and how we solve that, and then we'll use that case study to derive a generic quality of experience risk mitigation process guidelines or frameworks, so to speak. Then we'll have questions. So why quality of experience is a risk and a big risk? So let's take a kind of pop quiz. We're all engineers and we're used to go through quizzes, right? So consider 2 applications. One is I like it and drives me nut. I mean, the names are a giveaway, but I'll just give some sample user feedback, right? I'm using, say, for example, the audio quality was crisp and clear. So if you take a user which is taking a webinar, this is sample feedback. The audio quality was crisp and clear. Our webinar was a huge hit, and participants heard consistent pops in audio and webinars with occasional big drops. So the next feedback. So video quality is so seamless, it was like conversation is for real, and video had intermittent freezes throughout. So the 2 classes of feedbacks, and now the questions. So which product would you rather settle for, and which product would you rather recommend your friends, right? So I'll not ask for a show of hands because it's kind of a no-brainer here, right? So we'd like to just go and dissect, that feedback. So there is essential difference, between a classes of applications which are built on transactional processing from users' perspective. For example, airline ticket reservation system, right? So if you go to a website and buy an airline ticket, right, and as long as your payment is cleanly debited securely from your account, and you get a ticket to print, like you can wait for 20 seconds, to get the ticket, and you'll be happy customer. But what we're talking about here is human emotions, like human emotions getting exchanged through the service which is provided by this interactive, collaborative applications. And you don't want, while you're talking to your friend, you want to be oblivious of the technology around you. I think you don't want to, when suddenly the pops or like the glitches come in the headphones, you become aware of the headphones, like you become aware of the computer, right? And the entire human centeredness of the communication gets affected, right? So the example which I showed earlier, like the feedback was quite chalk and cheese, right? So it's not that way usually. It's very subtle, right? if you go back into the field, right, people have opinions about which is my preferred internet, web conferencing application. Like, I've heard people who prefer, say, Skype or GTAC over XYZ competitors. And if you ask them for why, like, they can't give you very specific reasons. They just say that, okay, I like it, right? That's kind of a general feedback. So there's kind of an opinion which builds over time, and it leads to the preference or rejection of application, which kinds of starts. The business is tightly, tied to the opinions, and of course, like preference is driven by perception, and perception spreads. So we can only ignore, like in the modern world of social intelligence, if you can call it, of Facebook. So if you have a preference, it spreads. It has its own way of spreading. It is so. So we better control the experience before it starts affecting our business. Okay, so that was the problem from a user experience perspective. So what's the problem from engineering perspective here? So I couldn't find the source of this graph, which I'm used to seeing this in some of the testing trainings, right? So I cannot quote the source, but this basically tries to brings that we would we're in the product life cycle. So as I think we were hearing in the morning sessions also, it's very costly to find a problem like bug here, and then you would like to find the same problems earlier in the life cycle. So the cost increases manifold as we start discovering the bug later. But that's not the real problem here. The real problem here is it's very counterintuitive to even acknowledge that experience is a risk. Why? Because risks are like human-centric and subjective, right? So I was just talking about the subtleness of opinions and how they start, building preference. So if you want to model that abstraction, you want to capture the attributes of that, it's very counterintuitive. And I'll tell, if you come down to the low-level specifics of this problem, we'll see that. So for example, I have a service which I give from Adobe Connect, and similar services are provided by, say, competitors or like companies like Cisco WebEx or Office Live Meeting. So one of the possible path of my stream delivery, which happens is like I have a Flash player, I have a meeting add-in, right? Meeting add-in is a special Flash player, which is built on top of Flash player. I have a Flash media server. I have a Flash media gateway, which bridges which is kind of protocol translator for the Flash RTMP protocol to the rest of the world, PSTN world. Well, it talks to the third-party conference service providers and SIP servers, and they finally land up at a telephone. So it's all happening. Only thing which I have in control over is this portion. This portion is in my control. I have this is in the clouds. This is in the clouds, and this is my system code. And I don't even own a lot of part of my system code which is delivering my service. So what happens is that the problem which it's get compounded is that each of the teams of these products which we own are separate teams. They're situated as separate geographies, and they don't always they are smart engineers who are making always improvising on the flow control and congestion control algorithms, and coming up with ways to optimize the service delivery of streams. But one person's gain is the other person's pain. It is so somebody when we try to combine the services of these teams, we get a different level of service which I promise to my customers, right? And in that situation, right, who is going to own the assurance of experience when I start integrating this different products, different the service provided by different products, which themselves are kind of distributed in nature. So I need to find a way to a deterministic way to do discover bugs in such kind of applications, quality of experience bugs. I use that term bugs because although it's kind of a I was one of the feedback I got was to use the term problem or issues, but I still use bug because that needs to be solved, and that's kind of when you solve the bug, you have a happy customer. So, so we want to, the first step towards solving, or if there is an experience problem, or a sure experience is to acknowledge that there is a problem, I think. And way to understand the problem is to measure it. So, we need to find ways to objectively and repeatedly measure and baseline such problems, which will, without which a very organized and structured debugging is not possible. So right now, the whole process of the experience problem discovery is ad hoc. Say at this point of time, my presentation is ad hoc. The debugging is quite unstructured, and the prevention is something which is way off. We first try to solve the problems. So, right. So, taking this concept, taking this preface of what we want to try to achieve, right? Let's go through a case study, which this is actually we solved a production quality of experience bug, and then we'll come back and see how we can derive, as I said in my parent agenda, that how we derive as generic risk mitigation process guidelines. Right. So here it's all started. It was around a couple of years back, right? So there was this feedback which we got from the field, and feedback was not very consistent. It was not like the product is bad. It was a certain percentage of users that when we have these meetings, when we have this audio conferencing meetings over a large number of audience, or even which is a meeting room which has more than 20, 30 participants or whatever. So the listener started experiencing small pops and glitches in the VoIP, right? And they seem to grow over time, right? And this is a random feedback, if you go back to developers or QE, the first thought, when they listen to the system, everything is fine, and the first thought is that, they must be imagining things, right? And it became a kind of a pattern, and the pattern was strong enough so that we could not ignore this sentiment, right? So we started to research, how do we solve this problem? So, as I said, so what are the challenges we face? Customer feedback started getting consistent, but we're not able to reproduce that in the labs. So, for example, when we started, when the developers in QE started working on that, so any random you start hearing noises, small pops, and they thought, okay, we have the problem, and that was kind of false positive because that didn't point to anything, and very strange, we used to go and search for people who are very sensitive to hearing. We want to, it's kind of crazy. We go and search for people who are strong at hearing, particular kinds of sounds, and it started crazy, managing the problem discovery and debugging process. And of course, things were the feedback from the customers was, we could not kind of get to the exact reproducibility of the problem to start solving it. And using third-party tools had inconsistent results. Why? We could have started measuring, the audio by recording. What happens with the third-party tools which are available is that they measure the audio and video of the sound card, right? And they put some algorithms and gather the quality metrics. Now, doing that is not tied to our system code, right? There are a lot of variables there. And more importantly, as we'll come to it, they give certain metrics which are quite esoteric, if I may call it, and I cannot directly map to my experience. So, and more importantly, they lie outside my product system code. So if I have to implement testability, I have no way to implement that. So this is what we came up with a hypothesis at that time, which kind of proved correct, that essentially, as I mentioned at the start of my presentation, that the entire service delivery, right, is happening over the web. So there is a single pipe which is delivering that service, the pipe which is coming, the network pipe, which is coming to the client. So essentially, there's an incoming multimedia data stream, which is hitting the transport layer interface, and it goes to our application layer, right? So the transport layer itself has a QoS parameters, like you can have a bandwidth conditions which are existing locally at the client at that time. There is a application layer QoS parameters, like parameters which I give in my client and the server, which start controlling the congestion control and the flow control algorithms, right? And on top of that, right, we have this quality of experience layer. Now that's an abstraction we want to quantify, right? And the hypothesis is that the quality of experience layer is some function of transport layer QoS and application layer QoS, right? So that's the hypothesis we started. So there's the point, like if we have to implement testability, that's the point we can start. We start owning our own system code. We can start putting hooks or writing APIs to get data to mine. So that's what we did, right? So what we did was that we put hooks at that interface of the transport layer and the application layer QoS and the flash player. And we started tracking, okay, that this audio packet has arrived now, right? So a couple of things. So we took input from cognitive psychology researches that human ear cannot discern disruptions in audio quality, if the audio quality in terms of pauses, right? If the two packets, the time between arrival of two packets is within 150 milliseconds. So that's the heuristic which we got. So essentially, what that means is that if the packets start arriving later than 150 milliseconds, there is a disruption to the experience. Now we want to mine how bad is that disruption, right? So that's the thing we want to quantify. So as I said, we implemented at the transport layer interface, we implemented a testability, to capture the arrival of a VoIP packet when they're coming. So essentially, so this is the simple math is also a measure of jitters, but we'll try to model this, measure in terms of what our customers are saying, and where do you want to go to solve the problem. So essentially, as I said, so we defined, so this is inter-packet delay, IPD. For packet n is time of arrival of packet n minus time of arrival of packet n minus 1. Right, so as I said, if we have the hypothesis that if the inter-packet delay is more than 150 milliseconds, we have a disruption, right? So we classified, so what we said was like, if IPD is less, inter-packet delay is less than 150 milliseconds, it's a good audio, it's a perfect audio. If it's more than 150 milliseconds, it's a pause, right? And we classified the pauses according to, according to the duration of the pause. So we called 150 millisecond and 400 millisecond. These are kind of configurable values, and we kind of evolved over, reset over time in terms of matching our customer feedback. But this is the kind of, the abstraction which we gathered from the duration of pauses, and this was the hypothesis. So what we did was that we implemented a visualization engine, right? And we started visualizing these packets as they're coming, and we started listening with our earphones. So it was kind of proof of concept because we could see the pauses, right? And rather than hear it, because we put engineers across, and we had this visualizer on, and we saw the big, we had this blue and red dots walk across, and there were big pauses. And okay, I heard a pause, and you see this big blue or red, which signifies the glitch along pause walk across. So it was kind of a assurance that we are on the right track. This is this is kind of giving us stats on the experience, and this is a potential way to baseline a wide quality of experience test. So moving ahead, I mean, so we started working on the metrics. So, but these were not these metrics were not time series metrics, right? So we need to convert them into time series metrics because that's the way we could baseline the test. I mean, we want to say that, hey, if I have polling the test, at a particular interval, if my monitor is or my agent is polling, then what is happening in that interval? I want to capture my test at that level, right? So there also we say that this was like a again, if you talk about experience of pauses, there are two measures to it. Is like how soon do the pauses occur, right? And how long are they when they do occur? Like, so if you take these two stats, these two stats, they kind of give me a, I can convert this into, a time series metric. So the measures which we got earlier, we converted that into frequency and duration distributions over time. And what we got was, a visualization or quantification of the experience. So at this point of time, so this is of course in reference to a standardized test or a test context, which I'll just come in a bit. So if we have a standardized test file, if we keep the condition, all the condition constant, and we are only varying one of the variables we would like to understand, then in that respect, we have a baseline. So this is an example of not a good test. Like you have lots of pauses. So you have lots of pauses here, which are over this. But there are some, phases in the test which are good, where we did not have any pause growth, and all the duration was within acceptable limits. So this kind of, we had a way to baseline the quality of experience test. So we went ahead, and now what it boils down was to, you set up a test matrix, which includes the context. You create a baseline test set with a high-risk context, and okay. Before that, we tried to regress the customer issue, and we had this test, and which proved that customer was correct. I mean, customers are always correct. So we saw that actually what they were saying were kind of getting that in numbers, that there are some disruptions in pauses occurring, and they seem to be growing over time. So this is kind of a long test. This is a 3.5-hour test, and they started building over time. So we got that, okay, we have found the problem, and we found this to be repeatable. So the two objectives, we had a measurement system in place. We found a way to, repeatably reproduce this problem in the lab. Okay, so as I was mentioning the baseline, so this is kind of we will not go too much into graph. It basically means that we created this baseline test, which have different parameters, and this is the developer side graph, where we kind of narrowed down that this area, which is creating pauses, this test 1, test 2, test 3 are basically a combination of our application layer QoS parameters at the client side and at the server side, and there was a injection at this point, right? And unfortunately, this setting was our default setting, right? So around 70% of the customers were hearing or experiencing the problem. So we went ahead. So the developers were able to identify the exact point in the code, the race condition, which actualized this problem, and they went ahead and fixed it. And sure enough, when we fixed it, right, when we regressed the build again, the problem was fixed, right? And we went back to the customers, and they validated it over time that it's coming fine, and you did a great job in solving that problem. So this was this was kind of a we started. So this gave us the confidence that we can apply this pattern, this in various areas. So the entire product, is built on features like this. So we have VoIP, we have whiteboards, we have screen sharing, which are typically happens in a conferencing or in an enterprise conferencing session, right? And we wanted to model this, take this pattern and try to use that in other features as well. So this is a summary of how we solved the bug. So as I said, we found a measurement method, right? And we could reproduce a problem in the lab. We could create baseline tests, and we could solve the problem. So one of the other things which were happening here at that, as we saw in that graphic of why baseline. So if I know the context and somebody gives me a why baseline, I can look at the graph and mention that the experience would have been like this without actually being present at the part of the test, without actually listening to the audio. So so there was this process of getting the experience scores unattended. So we wanted to quantify, standardize that process. Like we want to really what we want to do is put scores to the experience, right? And how do we kind of come to that? So in this section, we'll just try to see how do we mine the generic approach which we would take to do this the score mining, giving the scores rather than a human being having to analyze the metrics manually. We'll look at the test bed setup, and this was a as Esteban was mentioning yesterday, that we all have interpretations and of understanding of testability, particularly after this GTAC. So this is we discussed that how we can have automation in the test bed which aids the testability of this entire process, right? And we'll look at an example of how we can arrive at a QAT score decision tree and use it in, of course, in monitoring and baseline processes. So this is about the concept. So just to give so what we want to do is we want to arrive at the scores. We define the labels. So this is a supervised learning where we know the labels beforehand, and that helps at this point because we are dealing with, as I said, the human-centric attributes. So we would not get into clustering till beyond we understand the system better. So we, of course, we get the high-risk context. So as I said, every test baseline is reference to some context. And the context may be deterministic, which is from which can be managed from a application system code, right? Or the variables may be indeterministic, like user load, all right, or things like local bandwidth conditions, or usage profile. What kind of media profile is being used? Say using talk. Is it a conversation type of exchange, or is it music? When we are doing screen share, is it a fast motion exchange with a lot of colors, or it is a small a code review thing where the codec will take different paths depending on the kind of compression options available. So these are the contexts, but the idea is to identify the high risk context. We don't want to overdo these things. We want to use this for the most critical features. So we want to do a risk-based analysis of what are the contexts we want to include in the baseline test set, which is basically some kind of combination of this deterministic or indeterministic variables of the system. And of course, as I mentioned previously, so we have this QM metric, which itself is a function of QS parameters, which are whether they are the transport layer QS parameters or the application layer QS parameters existing at the client side. So armed with this too, I mean, this is just what we do is we create the training data, right? I mean, we carry out a test, we define, we derive the quality of experience classifier labels. We do the test so that the score classifier has high confidence and low impurity in terms of applying that in real life scenarios. And we pass it through the test data. And finally, what we have output of this is we create virtual observers. That is, we want to do the the experience mining unattended, rather than having to analyze all the tests and tests and respective context manually. So, and this is a very expensive process. Like, we want to carry out a lot of tests. We don't know what to do with the test results, and we invested on frameworks, to aid this process of I would say experience baselining. And so this is not so I'm part of the testing team. So probably I would not be able to show the demos, but pretty interesting demos it would have made. But one of the things we start with is like developing agents. So I was always fascinated by when I take my car to the workshop and they plug in that computer in the engine, and they can get all the stats of how my engine is doing. So we kind of replaced our client, so whatever meeting client we have, and we made a custom client which includes this quality of QS parameters and QoE parameters. After we have defined the decision tree, we can plug the QoE parameters also here, and we made this agent context aware. Like it can pick up context, like it can ping the server with a XML API call and pick up what's the load on my server like right now. Or it can pick up local context, like what is my CPU state of the client, or what is my network bandwidth of the client. So it picks up context. And we put these agents, and integrated these agents in different test processes, right? So we can put these agents or probes in our load test framework, or as part of our WAN emulation framework. Parallelly, we invested. So what happens? We invested on building a central QA architecture. So somebody, when using a test, so there are a lot of tests which needs to be done, and we don't want people to go and save the results manually somewhere and copy it to the file server. So we automated that part of the process. So we switch on the agent, the results, it picks up the information, the results get automatically archived at some remote location, right? And it provides some other services like statistical analysis services. We can observe these quality metrics in real time, right? We can do overlays. So there is essentially it provides the concept of client under test for quality of experience. And I mentioned the term quality of metric warehouse there because I call it a warehouse because it's one-way traffic, data goes in, and time is a very important dimension there. So this is the other thing which this agent helps us to do is to tag the context. Right? So I'm observing the test when I'm creating my when I'm doing my training tests. Is that I want to tag the context what I'm observing, right? Because that's very important in getting my quality of experience decision tree or classifier. So this is sample example of a video test. What we are doing is that the backend has a graded context. We are pushing the server with calls like 5 calls, 10 calls, 15 calls. These are the video calls which are coming on the server, and these are the two clients, which is one client is under LAN conditions. Sorry, one client is under LAN conditions, and the other client is a simulated DSL. I would say DSL conditions. And we start, the test is in progress, and this happens in real time, where I'm giving a representative view, we can just tag the labels, right? And what happens is that, so we have experience here, and we can just tag. So this is a concept of client under test. So there are two clients on the test which have two moving contexts. One is at the server side, which is load, and the other is at the client side, which is the changing of the local bandwidth conditions. So we tag these contexts, and these are very important. So when this test is saved, right, we have these metrics which are saved together with the context, which helps us in getting to the decision tree. So this is the classifier. For example, for the wipe, this is one of the sample simple classifier which I made. So for example, it has the context. The red boxes are the context, right? We have a default settings. We have one publisher or like one subscriber. That's the setup. The test site, these metrics would behave differently if we do it in the lab or if we do it in the production at the customer site. So based on the context and based on these quality of experience parameters, with what we can gather is the experience labels, right? So this is the classifier which we derived after doing a lot of baselining tests. So essentially, at this point of time, so if I have this metrics, and this is something which happens in real time, is that we have the metrics, we apply that classifier into the thing, and we can identify areas of experience disruptions at real time. This is something which we can directly put probes in our production systems to these tests, and they can based on some kind of alert models or rules, some clustering rules, these systems can send out feedback that, hey, I mean, for this period of time, your experience was not good enough. So this is one example of those automated alerts, in which say this for screen sharing latency. It gives me that there is an experience issue. It gives me the metrics and the clustering rule which it failed, and it also gives me the context, like the client and the server context. So it gives me very objective. So if there is a problem, we start seeing this pattern over time. It gives me what is the problem, right? The measurement of the problem and the possible ways to look to solve this problem for basically the developers. So we take the system back again. We use the same test we put in our CI test, and we get a label. So we hear whenever a new build comes in. So we have as I was saying, like we build a service out of integrating many products like Flash Media Server, Flash Media Gateway, Flash Player, and we integrate the whole system up in the continuous test bed, and we run this test as functional test. And what it sends out, as a week, is experience labels, experience codes. So if there's some disruptions, and we start observing them, we can go back to the developers and start solving them. So this is how we take the entire process and integrate into our baseline process, into monitoring process, into our this preventive process like continuous integration test, and we have labels coming on to mark the experience capability or experience delivering capability of the system which is being regressed. And of course, like this is all these tests we don't do it like we kind of standardize this test, and they always happen over a standardized context because we are kind of regressing them in the CI. So this is the summary of the QE risk mitigation process. We need to identify the QA risk and risk factors. We want to define the QA risk metrics, and we want to carry out proper relevance analysis of what QS parameters and what test context you want to use to have a measurement system in place. So that relevance analysis is very important. We develop the client-side agents. We run the tests. We create the baseline test. We model them for taking out the QE classifier or decision tree, and then we plug the QE classifier decision tree back into our monitoring systems, and you can get preventive alerts or scores based on clustering rule failures. So, and essentially parallelly what we have done is we have invested on creating a test automation infrastructure which doesn't solve this problem directly, but which aids the humans in carrying out this research and kind of get to the point of experience assurance at a faster pace. So that's a summary of the whole talk. So I'm done. So any questions?
Okay, from here. You mentioned
A code where the audio packet enters my application like as a RTMP packet. So Flash uses RTMP stream, and I could so as soon as I get a audio packet there, I just log the time of the arrival packet. So I used for example, we are dealing with inter-packet delay, so I use the Unix epoch time, and so that I can always get the time in milliseconds.
the reason why I'm asking this question is because when we were testing multimedia applications and we wanted to record the delays in terms of you might want to call it latency, we used an Adobe product to do that. Adobe Audition.
Yeah.
Okay, so why didn't you consider to use an Adobe product itself?
Yeah, because that's what I was saying. So why I could solve this problem, is that the point, I work in Adobe Connect. So this I put the hooks in the code in my system code. If I use Audition, right, it is as good as any other I would say audio capture and processing. I would say mining tool which records the audio of the sound card and will just lay out the wave pattern. So that is not very useful in debugging in my case, because there's a lot of variables introduced. So we are playing at the sub 150 millisecond range, and we don't want to get into how the audio processing is being done, how it is being handled to the sound card, how that is being rendered. So there's a lot of noise which gets introduced to my test results. So we wanted to capture it at the transport layer, the point which is coming through the pipe and hitting my application.
The quality agent that you mentioned on the client side, do you deploy that both to customers and to your quality, to your QA environment? So do you use that just for automatic tests or manual tests in your QA environment, or do you also monitor the production environment with that?
Yeah, it's both actually. So when we start out with this process, so so let me just go back. So when we start out this process, I think this step till here, this needs manual investment. Like you need humans to research and come up with a model, right? So once we have confidence on that model, we can go back and deploy that in production monitoring. So that's what we do. I mean, when it's kind of ready to show, we have high confidence and we kind of have metrics to measure the confidence. In that case, it gives very useful production monitoring results as well.
Hi. What kind of latency overhead does the monitoring introduce?
The
monitoring that you're doing of the packets, does it introduce any latency in the communications?
No, not really, because the latency so the point at which we are, so if you're taking a specific example, the point at which it is we're capturing the packet, that is the point where it is first hit. I mean, if latency is introduced, that is introduced post that. So that, and moreover, what happens is that, so we have kind of measured that aspect, and that has found to be negligible in terms of it's only 5% of noise it introduces. And the important part of it is that it's kind of common for all the tests, right? So that weight cancels out. If we are observing that in regressions, that weight is common for everything. So essentially, these things are useful when you start have a regression analysis, right? In that cases, the error which is introduced, which itself is not big enough to impact the test itself, that kind of cancels out, and we are left with we can do a regression comparison in that case.
I would have imagined that the traceability of the quality of experience issues would be a serious problem in practice. In the example you gave, it seemed like once the problem was identified, that the engineers didn't have much trouble identifying the cause of it. Is that a serious problem in practice? And if not, why not?
What is the problem which you talked about?
Identifying the cause, the root cause of the quality of experience issues.
So identifying, we work with this. I was mentioning that there are a lot of different products which provide the services. So this service is kind of an integration of a lot of these products. So it starts like you first when you start with you don't have any idea where the problem is, and you do this baseline test. You zoom in to a specific area, then you create test and you zoom in further, right? So one of the problems which this solves is that if I have a Flash team and a Flash media server team, they are separate teams. They develop separate algorithms for processing. So there is no owner. If you start owner to assure the services which is being delivered by a Flash player and Flash media server put together, and putting it in a different context. Like so one of the service offerings we have is hosted, which is delivered as an enterprise SaaS service. So there are a lot of other external factors come into the picture. For example, we have third-party conference service providers like Avaya and Rebate, who kind of pitch in to give certain services, service offerings. So these teams, how these features play out in the context of the, when you throw them back into the world in random situations which have random causes, so we kind of try to create ownership of that part. Like, when we integrate this and we integrate it with the real life use cases, these are the boundaries of service. So one of the other important aspect of this is like, we always take these baselines back to the product management and say that, hey, your audio is not going to work if there are 20 people speaking at a time in the meeting. Is it okay, right? Are you fine with that, right? They said, okay, we are fine, or like, we can call it out in the tech notes or whatever, right? So this also helps to define the boundaries of the system and which is acceptable to users and whether those are conforming to our business objectives. Yeah, actually, that's applicable for things like a VoIP. So we had started on that because the MOS score and the R factors, right? So again, the way to so we calculate those MOS scores are out of getting the sound out of some sound of the sound. Recording the sound off the sound card and then putting a tool to gather that metrics. So that kind of didn't assure us of where we are going in terms of pauses. So this is kind of, we wanted to track metrics in terms of pauses. So they were at a different level of abstraction, and they were not kind of pointing to the portions of our code which are solving the problem. But what we are trying to do now is that we have enough information from within the product itself that we can apply the MOS score algorithms to create a quality score based on MOS rather than this. So that's kind of in progress. We are just going through the research papers and applying the same RFCs to calculate the MOS scores out of the product parameters itself. Yeah. So thank you, everybody, and thank you again for giving me this opportunity to speak at GTAC. Thank you.